Welcome to a short overview of Ceph storage in Dell OpenStack-Powered Cloud Solutions. Ceph is a transformational storage technology available as free open-source software. It's a universal storage solution that provides block, file, and object storage from a scalable cluster built on top of standard utility server hardware. Dell has partnered with Inktank, the Ceph experts, to bring a validated Ceph storage solution to Dell Cloud customers. Inktank is a strategic partner in Dell's Emerging Solutions Ecosystem Partner Program. Ecosystem partners work with Dell to deliver complementary components that can be deployed as part of Dell OpenStack-Powered Cloud Solutions. As part of this program, Dell and Inktank provide Ceph expertise. Ceph adds scalable cloud storage to the Dell OpenStack-Powered Cloud and integrates with Crowbar to provision and configure a Ceph cluster. The partnership will deliver professional services, support, and training for Dell customers and provide the confidence of knowing a complete solution has been validated with the Dell reference architecture as part of the Technology Partner Program. Since its beginning, OpenStack has used local disk and Swift as native storage options. They work, but they have their limitations. Swift is primarily an object storage solution, and while it can hold images, it imposes awkward workflows for VM instances. In addition, it's not suitable when high throughput, low latency, or file system access is needed by OpenStack applications. Ceph addresses these gaps and makes an ideal OpenStack block storage provider for applications and VM instances. It's integrated with Crowbar and makes it simple to provision and configure a Ceph cluster on Dell server hardware. Ceph has been tested and validated as part of a Dell OpenStack solution, and Ceph developers have been participating in the evolution of OpenStack for several years. More importantly, Ceph can save customers lots of money by delivering the capabilities of expensive proprietary systems at utility hardware prices. Ceph and Inktank exist to address the storage challenges of today's marketplace. Ceph was built to scale cost-effectively, enabling efficient operation at massive scales through flexible self-management and healing. Ceph is the best block storage solution in OpenStack and provides scalable, resilient images and volumes for OpenStack VM instances. With no software licensing fees and commodity hardware, cost per gigabyte is much lower than proprietary alternatives. Ceph provides advanced block storage capabilities, such as easy spin-up, backup, and cloning of VMs. In addition, using Ceph provides valuable capabilities that make OpenStack more useful. For example, persistence. Ceph volumes in OpenStack are persistent by default, so you can have VMs that behave more like traditional servers. Their state doesn't disappear when you reboot them. Another feature is that Ceph-backed VMs are not tied to a single host. Because Ceph volumes and images are stored in a shared storage system, VMs can be migrated, compute and storage resources can be scaled independently, compute hosts can be diskless. In addition, a range of advanced storage system features are available. Different types of storage, for example, fast versus slow or replicator versus single copy, can be accessed from the same compute host. Snapshots can be created directly by the storage system. As a universal storage system, Ceph can be used in a wide range of situations. Ceph can be used to build a RESTful object store compatible with Amazon S3. It can be used to provide VM storage needed to rapidly provision massive virtual infrastructures. This is the primary use case for Dell OpenStack-Powered Cloud Solution customers. Ceph can also be a scalable and affordable alternative to more traditional enterprise storage solutions. In high-performance computing environments, Ceph's scale and performance can satisfy intensive requirements. Big data projects benefit from Ceph's scalability and performance, and developers working on data-intensive applications can integrate Ceph directly into their software for fast operations and massive scale. As an open-source software solution, Ceph will continue to rapidly evolve and adapt to better meet these and emerging needs. Inktank's culture is all about collaboration and transparency. The licensing and copyright policies on Ceph guarantee that it will always be open source, and Inktank is committed to fostering the continued growth of a diverse, inclusive community. Ceph has also been an active member of the Linux and OpenStack communities. Ceph has been integrated with the Linux kernel for several years, and is also integrated with OpenStack and Ubuntu. The unified access methods allow a wide range of use cases. Developers and applications within a single organization often prefer and require different types of storage technologies. Many legacy applications use block storage. Many developers find it easier to work with file system storage, but more and more developers are also becoming aware of the performance, flexibility, and cost benefits of using an object storage model. Ceph provides the most flexibility and enables organizations to use a single platform to support the widest range of use cases. No other free open source solution is as flexible, and no other commercial solution can provide as much value. Let's take a look at a couple of the most popular use cases. Service providers planning to field public and private clouds are evaluating and deploying Ceph technology. Not only is it a great fit for large-scale clouds, but integration with OpenStack, Crowbar, and Ceph make it easy to deploy and manage. As one example, consider DreamHost. DreamHost has deployed nearly 7 petabytes of storage with Ceph on Dell hardware. They are providing cloud compute and storage services and are confident that Ceph and OpenStack will scale with them for whatever level is required. Another use case is application development and testing. Many organizations are starting to develop for cloud deployments or leveraging their cloud architectures to build flexible infrastructures for their developer teams. Many are not storage experts, but have requirements for reliable storage that can scale to the level envisioned for the applications. Ceph makes that possible and provides APIs that make it simple to not only use Ceph for the infrastructure, but also integrate Ceph directly into their applications. Lastly, another use area to keep in mind is for backup and archive. Because the data tends to be one of many copies, many organizations feel more comfortable deploying new storage technologies for backup and archive before using it for primary storage. In addition, organizations that need to store many petabytes of data benefit from the lower cost and ability to have access to the source code over the long term. Now let's take a look at how Ceph integrates with Crowbar and OpenStack. The next few minutes demonstrate key activities using Ceph hands-on. Crowbar modules are called bar clamps. To use Ceph and OpenStack, we must first upload and install 2 new bar clamps using the Crowbar web interface. The Ceph bar clamp installs knowledge of how to deploy Ceph in the cluster. The new Nova bar clamps updates existing Nova bar clamps with the ability to use Ceph for volumes and images. So in this part of the demo, we'll show how the new Ceph and Nova updated bar clamps are installed. First thing we're going to do is connect to our newly installed admin node. And, we basically see there's a single node. It's the admin. We're going to go to Utilities and Import Bar Clamps, and then browse to the location with the new bar clamps. So we're going to upload first the Ceph bar clamp, to authenticate, and then the upload succeeds. And then we're going to browse to the updated Nova bar clamp, which includes the Ceph integration, and upload that as well. So we now have the 2 new bar clamps available, and then we click the import button to get them processed into the system. We're doing this first thing after we install the admin node, so that the new bar clamps are going to be integrated and available to all of the nodes that get added to the system later on. So basically, after this is all done, we should see the import log, and it should all look successful. And after that's done, the bar clamps start getting installed into the system, and you see that the web server process needs to restart, along with some other stuff that gets regenerated. So this will spin for a while, but basically it's just restarting the web server. If we go back to the dashboard, we should see the node back up and running. And at this point, the new bar clamp should be installed on the admin node and available for deployment to the different nodes that get added to the cluster later on, including the Ceph proposal that we'll create later. To deploy Ceph within OpenStack, we need to first create and apply a new Ceph proposal. Crowbar proposals describe the mapping between nodes and roles for a particular set of capabilities. They also provide a way of configuring various options for the capability and are persistent across node reinstallation. Let's take a look at what that looks like in action. So in this part of the demo, we're going to show what it looks like to create a proposal for Ceph. We have a system now with the admin node and 6 compute nodes, or just nodes in the cluster. If we go to bar clamps, we'll see that there's now a Ceph bar clamp, which is what we installed in the earlier demonstration. We're going to go and create a new proposal for Ceph and assign nodes to the various roles. So what we're going to do is place node 1 as a Ceph monitor, node 2 as a Ceph monitor, and let's go with node 5 as a Ceph monitor as well. And let's select nodes 2, 3, and 4 to be Ceph storage nodes. The Ceph client role is inherent in the updated Nova bar clamp, so it doesn't really need to be explicitly assigned right now. Once we've assigned the roles, we're going to apply it. At this point, we're going to wait for a little while for the proposal to get applied, the various software bits being deployed to the nodes, and them starting up with that role. Things transition to being in progress. You can kind of see the little icon LED showing that it's working, and we'll just keep making some progress. So while the proposal is applying, if we go to the dashboard page again, you'll see the nodes that were assigned roles in the Ceph proposal also in the process of applying the proposal. This can take a little while. It takes a while to deploy all the functionality to the various nodes. So, give yourself at least several minutes for the Ceph proposal to get fully applied. And, sometimes it might take more if there's more disks that are getting incorporated into Ceph as well. So once the proposal successfully gets applied, you should see this message. If you go back to the node dashboard and check out one of the nodes, you should see that it has the Ceph bar clamp installed, and then it has the appropriate roles. So like, for example, node 3 was one of the Ceph store roles, and you should see that role defined as well. The one other thing that's worth pointing out here is if you go to the VLANs, the nodes that were tagged for inclusion in that proposal should now be connected to the storage VLAN. And then if you go to bar clamps, you'll see the Ceph bar clamp now has a green status. At this point, just kind of go and apply all of the OpenStack proposals in order, and they should be able to leverage Ceph for the storage functionality. The implication there is apply the Ceph proposal first. That's the end of this portion of the demonstration. Once the Ceph proposal has been successfully applied, it's a good idea to just check on the Ceph cluster health. And to do that, what we can do is connect to the admin node, and then from there SSH into one of the nodes that has a monitor role. Once we are on that node, we can run the ceph-s command to check Ceph status. And what we should be looking for is, health okay, that the monitors are up and running, and that we have a quorum with at least 2 nodes in it. The OSDs are all up and in the cluster, and then everything is active and clean. So this is really kind of an ideally healthy system state. If we do Ceph OSD tree, we can get an ASCII representation of what the disks in the Ceph cluster look like. So we have basically 3 hosts that have the Ceph store role in the cluster. Each of them has 4 disks, and those disks are up and part of the cluster. So at this point, we know that we have a healthy Ceph storage cluster running as part of this OpenStack deployment. Once Ceph is integrated with the cluster, volumes can be created and deleted directly from the Nova dashboard. Let's see what that looks like. Once all of the proposals have been applied by Crowbar, we should have a successfully deployed OpenStack cluster. You could take a look using the overview page and you should see all the different components lit up and bright. We also have Nagios up and running, showing health for the cluster, as well as Ganglia showing utilization and how everything is doing. What we want to do next is get onto the dashboard for OpenStack, and to do that we need to go to Node 1, and then we can just click the Nova dashboard link, and it should take us to the dashboard. The next part of the demo would be to demonstrate how we can create a volume using the dashboard and have that volume be automatically stored in Ceph. So to do that, we go to the Instances and Volumes page, click the Create Volume button, give the volume a name and a size, click the Create Volume button. At this point, we should have the new volume available over here. If we click the Detail page, we see a little bit more information about that volume. Now, the next stage is really just to validate that this got created inside of Ceph, and to do that, we're going to go to the admin node and SSH into one of the nodes that's running the monitor role. On this node, what we can do is use the RBD command for Rado's block device and get a list of volumes. So we see that we now have this volume 2. And that volume corresponds to the volume we just created above. It got created in Ceph, and now if we go back here and delete this volume, we should also see that the volume is no longer there in Ceph. So what we've done now is demonstrated that we can create and delete volumes using the Nova dashboard for OpenStack, and those volumes are stored using the Ceph cluster that we've instantiated as part of the OpenStack cluster. Ceph also allows OpenStack users to create persistent bootable volumes. The volumes live in Ceph and are accessible from any host, enabling VM migration. Let's see what that involves. Now let's demonstrate creating a bootable volume. What we're going to do is create a volume just like we did before. Give it a name. And the size. And then select Create Volume. So we now have this volume that's registered as bootable and stored in Ceph. What we're going to do is go on to the node like we did before and see that this volume is called volume 4. And if we get some info on this new volume, we'll see that it's 10 gigs in size like we said before on the dashboard. Now what we're going to do is remove this volume because we don't actually need the volume content. What we do need is that volume to be registered with the OpenStack dashboard as an existing volume. And instead what we will do is recreate this volume with the same name, but by importing a image that we downloaded from some Linux distribution. So for example, here I have the precise server cloud image. And what we can do is we could say rbd import and into the volume name. And at this point, Ceph will start creating a new volume with the volume 4 name by importing the contents of that image that we downloaded and made available. It takes a little while, especially on a demo VM system. Now if we do this info command again, we should see that the volume is about the same size that the precise image was. Well, I guess this is linked somewhere else, but it's about 1.4 gigs. And if we go back to the dashboard, we'll see that the volume is over here. And the next step will be to launch an instance based on this bootable volume. So to do that, we'll go to Images and Snapshots, because we need an image from which to launch a new instance. That's part of how OpenStack works these days. So to do that, we've created this bare image. It's basically a 0-byte image just to have something to launch from. And what we will do is launch a new instance from this. We're going to give it a name. And over here on the bottom, what we're going to do is select boot from volume and select our bootable volume that we've populated with an image before. And then when we're ready, click the Launch Instance button. This will take us to the Instances and Volumes menu. We can see that it's starting to build and spawning the task. And at this point, our demo instance is running. So we've created a bootable volume by populating it in Ceph with a bootable image, and then created a new instance that booted from that bootable volume. We hope you found this overview useful and learned all about Ceph storage as part of the Dell OpenStack-Powered Cloud Solution. Ceph is transformational storage software, available as free open source. It's a universal storage solution that provides block, file, and object storage from a shared storage cluster built on standard utility server hardware. Dell has partnered with Inktank, the Ceph experts, to bring a validated Ceph storage solution to Dell Cloud customers. Please consult Dell, Inktank, and expert blog websites for more information. Thank you.